close to the end of day one. I know it's been a long day, and I could have shown you all our wonderful regulations and make you fall asleep, but you know, now's not the time. So just so I know who I'm talking to, how many lawyers are in the room? Or one of you, I mean, people studying to be lawyers? Not too many. Engineers? Okay, this is easy. And this one? All right, there are about 20 slides, don't worry, it's not all me talking. And what I try to do is, although I'm getting there with the age, I try to use a little emoji there. So if you happen to feel about the slide the way the emoji is telling you to feel about the slide, then I guess I'm kind of on track with responding, reacting to you. One day, hopefully, we get like live emojis while the speaker's talking, so we can necessarily get the feedback while we talk. I use this title a little provocatively, but just so you know, the big elephant in the room for a lot of this new commercial space stuff is that the industry doesn't want the regulators to go so heavy on them that the industry cannot get off the ground. If you think of the Concorde, we're in the 21st century, there isn't a single supersonic aircraft flying around on a commercial basis. I'm an aeronautical engineer. I think the Concorde was a pretty good airplane. Especially if you think that in 1969, when it started flying, it was a very modern aircraft. The 747 started flying around the same time. So why is the Concorde thought of as an outdated piece of equipment? Well, that's because they never got enough orders for them to streamline the production of the aircraft. So 30 years later, while the 747 was in the 6th generation, the Concorde was still stuck in its 1st generation. In other words, we're flying 69 technology in the year 2000, where the 747, because of the economically viable piece, had been allowed to become more environmentally friendly, to become more efficient. And I would say, even though it might not be too many orders around, it's still probably one of the best ones out there. So we don't want that to happen to this area. I'm from the International Civil Aviation Organization, an organization that is known amongst engineers as, oh no, not those guys again, because we're the ones who set the international standards. So what do? I'm going to get through these slides pretty quickly because I'm not going to bore you with these things. As you can see, the is pretty tired. And what we do basically is that if you want to fly from one country to another country or over another country, you need international agreements. Now, for those who know about permutation, if you have 191 countries in the world and you do it bilaterally, that's a really big number of bilateral agreements, whereas if you have one international treaty, it's just a lot easier. And of course, no engineer is going to be able to deliver an aircraft that in the middle of the flight, as it passes from one country to another country, changes its configuration. So we do that. We harmonize the requirements for aviation. So what has that got to do with space? Because in space, you go up and down. I mean, sub-orbital, what Virgin's doing, it's not even international traffic. And other people who may go one day from point A to point B are going to spend maybe that much time in the atmosphere where aircraft fly. So I'm here to kind of start showing you why we're involved. So a few profiles. This one, as you can see, is an air launch, so it's definitely related to aviation. This is the Dream Chaser. Dream Chaser, it wants to tell everybody in the world that this particular thing can land anywhere a 737 or an A320 can land. They're trying to leverage aviation infrastructure for that. This is one of the many Airbus concepts, and as you can see, it's a powered flight on the way back down. It's not a glider like for the Virgin Galactic, which is a glider on the way down, but is air-launched because it rides on top of a plane. But I'm sure many of you already know these things. And it's not just the airplanes. Many people want to use existing aviation infrastructure on the ground. This is a satellite image of Mojave Aerospace Board, which, as far as I know, was the first commercially operated air and spaceport where half of its revenue is through the space and rocket technology business. So we are involved, and when we get involved, some guys get a little worried because you may have some idea that your ticket, your plane ticket cost is a lot higher because regulation costs a lot in aviation. There is a lot of people involved in the regulatory side of aviation, purely because we're trying to make sure, of course, that there are fewer and fewer crashes. But the title of my presentation is that we shouldn't make the laws of man more insurmountable laws of physics. So this is, law. This is the universal law for gravity, and this is what I'm trying to compare. And this is not a numbers thing. This is not a qualitative thing. This is more, it's not a quantitative thing. It's a qualitative thing. And so for my complicated slide, so we're trying to just put our heads around what does it mean? What do I mean when I say the cost of the work you need to put into regulation, to following regulation? And so I've got an equation here which just says the first one is pretty much that whatever the force you have to contend with here is some constant, so you always need a constant for every single formula you put in. And then the C1 is the complexity. It's actually a CL. It's the complexity of your operation. If you have one aircraft and you're flying to one place in the world, you have a far less complex operation than if you're flying to 20 countries with a fleet of 20 different types of planes. And then where you see all the E's, that's basically to see what the relationship is between how much effort you have to do to comply with regulation and the nature of that regulation itself. So the R is the rate at which we change regulation. The CG, the CR, and CN is the complexity of regulation at the global, regional, and national level, which is then summarized because you have so many E's there, you can put it together as one SR. And for those of you who are familiar with the concept of entropy, I stole that S from entropy. So basically, all I'm saying here is that you can make certain elements. I mean, there's this complexity of regulations. And if you make it too complex, it becomes very difficult to comply with it. Just one thing I'll note, the R is the rate of change of regulation. So you may know that in ICAO we have a lot of standards, I'll tell you later how many, but we change them at quite a high pace. And we've noticed that it takes countries about 5 years to absorb the change because it's the nature of aviation. Now, if we're changing them every 2 years, but the system can only absorb that change every 5 years, well, that's the definition of turbulence, that the system, you're changing the system quicker than it can respond to that change. So just keep that in mind, because I'll come back to that later. But this is just, again, I'm not just an engineer, I'm also a geek, so I need these things. Now, if I just told you that there is this entropic relationship of law and the cost of implementing law, someone's going to say, wait a second. The reason we have law is to enforce order that isn't there naturally. So it is actually a way to bring order into disorder. And so here, just a graph that kind of, I try to reflect this a bit. You have the complexity on one line, and you have risk on the other. And there is a line called acceptable level of safety. If you're aware with the concept of safety management, you have to know what is that number you're designing your system for. So this is, of course, not at all mathematically correct. I'm just drawing, or actually I'm getting PowerPoint to draw these things for me. But I think you can agree, if you do nothing, if you just let aviation happen with no regulation, at some point the complexity just goes through that safety line. So we have to do stuff, we have to write those laws to stop it from getting to that line. If you write prescriptive laws or prescriptive regulations, so regulations that are tailored to the actual operation that's happening, then what you really do is you shift this graph to the left, right. So if you have a 747 come online, you write regulation 747. You have you have A380, you write regulation A380. You're always trying to shift that line so that you are stay ahead of complexity. But again, if at any point you stop writing regulation, you'll go through that safety level because at some point the nature of that business has changed. So is there anything we can do to write regulation that is adaptive to a changing environment? Something that would do something like this. So you have a regulation that is asymptotically always going to be against that acceptable level of safety. The good news is we think, yes, we can. The bad news is it's extremely complicated. I spoke about prescription earlier, and this is a graph that is probably accurate to 1 degree, one significant degree. Basically, in aviation, we have about 10,000 regulations internationally, and we have achieved the safety level that is often quoted as 10 to the minus 9. I understand from my space colleagues that the space shuttle ran on a set of regulations that was 70 pages, much less, and they achieved the 10 to the minus 2 kind of safety rating. And I have a helicopter that really is offshore operations, so people who take helicopters to all areas. They're about an order of magnitude less regulations for them, and we have it into the minus rating. This slide I'm showing because there is an illusion in numbers. One would look at this and say, oh, so writing prescriptive standards, if you have 10,000, you get to minus 9. If you have 100, you only get minus 2. So why don't we just write 10,000 standards for space? So the illusion I represent by this graph. What you see here is our latest numbers for safety in aviation. And you can kind of see the first one, which is the accident rate in 2016, shown as graphs against it. And then the second one is a fatality. So it's top left and top right. What I think you can notice is that we're starting to get to the point where we're flat. We're starting to get to the point that writing more regulations the way we used to is not necessarily going to increase our safety levels, because the system has reached the saturation point for the accident rate. So in aviation, we developed something called performance-based standards. Okay, so real quick, if you tell someone to do something, then it's prescription. If you describe to him how he should behave, it's performance-based. What you see on the screen, and if you can read this, then that'd be interesting. This is our prescribed definition for what an accident is. And just the top of it is this part. This is, if you look at it, just one phrase. An occurrence associated with the operation of aircraft, which, in the case of manned aircraft, takes place between any time a person boards an aircraft with the intention of flight, until such time all persons depart, or in the case of unmanned aircraft, level 1. This is how we are defining accidents. And I think you can kind of see that we should maybe not need this kind of sentence for people to understand if something happened that should be investigated to help future things from being prevented. Because the only reason we investigate accidents is to prevent future accidents from happening. So when you look at this, and this entire second half that says in case of unmanned was added because no one could figure out what the equivalent of someone being on board of the aircraft with the intention of flight was for an unmanned aircraft. And I can tell you, there was a lot of people in a lot of rooms coming up with this sentence. So We need to move towards something that is performance-based because it will be adaptive to this future. Now, that's really easy for me to say, but let me just take you through one very exaggerated example. So if all I have to do is tell people how to perform, I just need one step. Don't crash. Or in this country. And then that's it. You're fine. I'll sign off any approvals you want. Just don't crash. So we have these two extremes. We have the one where we're trying to figure out, how do I word this in the right way? I mean, go back to the previous slide, you may have noticed it said an accident is when someone's on board the aircraft with the intent to fly. We had an A340 in a maintenance bay. Two guys got on the plane, two pilots got on the plane, wrapped up all 4 engines to do a brake test. They didn't realize the brakes on the A340 has 4 engines. It is not designed to withstand the force of all 4 engines at the same time, so it started to roll. They couldn't stop it. They didn't know what was going on, and it almost killed someone. In our definition, it's not an accident because the guys were not on board of the aircraft with the intent to fly. But if you think about safety, you say that's a safety issue. There's surely something we can learn from that to avoid accidents in the future. So, all of this gelled for a while, and now, after I think 50 years of existence, 60 years of existence, ICAO recently, this is maybe 7 years ago, we have a definition of safety. So if you read, it says a state in which risks associated with aviation activities are reduced in control to an acceptable level. So that means if you happen to have no accidents, but it's pure luck, it's not safe. But you see that this definition will adapt with whatever environment we're looking at. So if I'm looking at some orbital operation, I'm looking at just the guy walking the street. This actually works even outside of traditional aviation. But it comes with a very heavy duty, and that is risks associated are reduced and controlled. A lot of people, okay, you're younger folks, you may not have the same problem I have. I do this, with my house, it's called mortgage. It's risks associated with my going bankrupt in order for me to have some profit. In aviation, what this means is that there is a non-traditional element, that of risk assessment and risk management, that is being brought into the fold. And if you know aviation, we're like a 10,000-hour club. Normally, you cannot even talk to aviation people unless you can have some credentials or 4 stripes on some shirt or some, right? So this is a cultural shift. And if you remember that green line, it has a point of inflection. It's because that as you introduce these new types of regulations, you have to let go sometimes of the old one. Because you cannot be, on the one hand, prescribing what they should do and then telling them how to perform. I'm Asian, I know, my parents tried that with me. It doesn't work. Okay. I will either achieve what they want or I'll do what they tell me. But I'm not sure I can do both in a world that is moved on from. So this is, I know we're a very short time here, but just kind of to bring you to kind of the way of thinking. Come back quickly to the subject of space. So we now need to know in ICAO, how do I now write 10,000 standards, but still achieve the performance? So I'm going to go through this slide really quickly in the interest of time and just general interest. But what you see here is that first we figure out what needs to be done. So for commercial space transport, we're talking about 3 or 4 countries and very sophisticated aviation environments. You're not talking about someone leasing the Virgin type operation in a country that's still struggling with basic aviation. And so that's the top. We do the needs analysis. Then the bottom, the blue part has 2 parts. Okay? One is, what is the regulation? What needs to be harmonized? Absolutely needs to be harmonized. And the second part is what does it take to get this stuff done? And they're supported on the bottom by two big boxes. One are the standards, the ICAO standards, the national standards, and the industry standards. And the second part is the guidance. So as you move from prescribing things, like you must have seatbelts, to you must not, to performance, which would say something like you have to make sure that everything's been done to protect the infants on board of an aircraft, then the prescribed seatbelt regulation will move from the left bottom over to the right, where there'll be a standard practice that the easiest way to meet that standard or that performance is with seatbelts. But if tomorrow someone invents technology that can meet the same performance, I don't need a regulatory process to change regulations and keep that technology from being used while the regulators figure out whether it works. So it's a little provocative for many people in the more traditional area. And it is provocative because they're afraid of having to do that thing that they might not know how to do, which is risk assessment. So this is the last slide I have. It's a bit, in ICAO we've had many people come to us and say, you gotta start regulating the Virgin Galactics and SpaceX, and we sit there and we say, why? What is it that you need? Because they come to us and they tell us what they need, and our response is, okay, let me show you how to live without it. But always keeping our responsibility for safety. And that one, I think, is, in this room, is going to be less of an issue. If we had more lawyers, maybe I would be standing here right now. But we have to understand as regulators that we are enablers of modern technology. We're not the guy who tells modern technology what they can or cannot do. But for that, and this is the message we give to the industry should understand how regulators are on their critical path. And when they understand that, then they understand how to avoid something like Concorde happening again. So I know a lot of stuff in a really short time, late on Thursday afternoon, so I apologize for that, but hopefully it starts many conversations internally amongst yourselves.